Is length. It's composed of one facet. It's primal. It's a line. There is minimal analysis because there is nothing except a line. It's basic fact. It's the distance between France and India. It's my height when I was 7. It measures one thing. Think of a ruler or a meter stick. It's a single line. The second dimension incorporates length and width. It's the basic graph, comparing any two variables, for example, distance versus time. The Greek mathematician Euclid created geometry with only 2 axes. Newton established his laws of motion using only 2 axes. Most of economic theory was developed using 2 axes. As you can see, 2 axes have been utilized for most of history to visually portray our understanding of the world around us. The use of 2 axes squared the amount of information available to the world previously. The third dimension is made up of length, width, and height. In this dimension, objects are solid. It is the domain of substance. In this dimension, data can be portrayed into human perception because most humans only conceive of the third dimension. In three-dimensional visual data, we can create visual maps that detail the complex underground strata that bears oil and natural gas, reducing the millions of dollars wasted on drilling dry holes. 3D analysis can be used to create accurate representations of buildings and historic landmarks, such as this representation of St. Basil's Cathedral, created by Arrigo Silva. It can also be used in math classrooms. 3D graphing software provides students with an accurate depiction of the different components of an equation and their impacts on the graph. The fourth dimension is comprised of length, width, height, and time or space. The fourth dimension was proposed by Einstein in his general and special theories of relativity. Einstein predicted that time and space are the same thing. We have just started to be able to create programs that analyze in the fourth dimension. This is gapminder. It looks similar to normal two-dimensional graphs. However, it can chart in the fourth dimension by utilizing color, size, and location of the data points to go beyond just the X and Y axes. This multi-dimensional rendering of the universe and its complexities was created by the American Museum of Natural History. It is an excellent example of visual data analysis because it uses time, space, length, width, and height to portray the distance that light travels in a year. String theory was postulated by Gabriele Veziano. According to string theory, there are 10 or 11 dimensions that make up existence. Perhaps we will be able to one day process data in the 11th dimension. We can't possibly imagine what such technologies would look like, or even how they would function, because we cannot perceive beyond the fourth dimension. String theory and its extra dimensions are the future of visual data analysis.